Question number 1 is asking us to assign a variable x, which becomes a row vector, and we're going to have it evenly spaced between 0 and pi. Then we're going to compute a function f of x at each of these endpoints and create a vector y, which has all these points. Then we're going to display the 31st element of y, and we're going to format it to only have 3 digits after the decimal. And then finally, we're going to graph this on a figure, and we're going to have x as the horizontal axis and y as the vertical axis. So let's start off with A. So it says assign a variable x to 1 by 200 row vector. So we know it's going to have an x is going to look something similar to like this, which is x2, and then dot 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 all the way through x200. So if it says evenly spaced values between 0 and pi, first thing you should think of is a linspace. So let's just make our first line x. Let's just make our first line for now. X equals linspace. And then we'll have the first value is 0, last value is pi, so that's the first value, last value, and then that amount of points that you want to have. So you want 200 columns, so you're going to put 200 right here, and that'll have evenly spaced, and that will include the endpoints. Then we want to compute these values at every single point and create a y vector. So the vector y is going to be similar to like y1, y2, all the way through y200. So if we're going to do this, we're going to have to do vector operations. So let's compute this. We're going to call this y. We're going to do exp, which is just exponent of -2 times x. And since this is a scalar, you don't need a dot times. You just need a -2 times x. Then we're going to do dot multiply because this by itself creates a vector, and then the sign function over here is also going to create a vector by itself. So you have to do dot multiply sign, and then we have x, and then dot to the power of 3 because every single value of x needs to go to the power of 3. So that's our y. Then we're going to display the 31st element with only 3 digits. So we're just going to use fprintf for that. So if we're going to do any formatting like this, we have to do fprintf. So we'll do fprint. And we don't have to assign this to any variable. Just say fprintf, and you have your parentheses. Then you have a string, so you put your first apostrophe, and we're going to use percent, and we're going to do 0.3f. So that's going to tell us that we're going to have, after our decimal point, we're going to have 3 values, and f is just float, which means just decimal. That's all it really means. And I'm just going to do /n, and then another to end off the string. This will just create a new line to make it look nicer. Put comma, and then now whatever this number is, we're going to have to put it in here so that it can like basically put it back in there and display it. So we're going to do y, and we're going to index it of 31 because we want the 31st value, right? So that's our last one. And then our fourth line is just going to have to graph all these points. So that will just be plot x, y, and then it asks you to keep it as a solid line, which is default. But if you'd like to know how to do that, you just put a string here, and you just put a dash, and then end the string here, and then close the parentheses. And I'll just tell you that your format is you have just solid line going through, and that's how you do number 1. If we actually try to plot problem number 1, like we had x equals linspace of 0, pi, and that's how you write pi actually. You have to put pi, not just the symbol. You put 200. We got y, and I put brackets here just to emphasize that it's a vector. And you assign it to exp, like we said, -2 times x, and then dot multiply sign of x dot caret, or to the power of 3. Then we got fprintf, and that's just how we can format. We have percent 0.3f, that's our number, and then new line character, so, oh shoot, right here. So we have /n, that makes it look nicer, and this just assigns the number to percent 0.3f, and we just plot it. And so if we just write the name of the script, so problem 1, we're going to get this graph right here like we plotted it. And then if we look down here, we got x, and that has 200 values. It goes to 200, and if you look at this value right here, this is pi. And for y, it just computes them all, and we get this graph right here.